You're listening to Engineuity, the podcast that dives into the wonderful world of everything industrial. From the birth of the first combustion engine to breakthrough hybrid power technologies, Engineuity examines just about everything the industry has to offer. The podcast provides a platform for industry leaders, engineers, scientists, and small business owners to educate listeners about past, present, and future industries across the planet.
Welcome to Engineuity Episode 8. I'm lucky to be joined today by Laura Kennedy, the president and owner of Global Power Technologies. Laura, if you could maybe just give us a quick introduction to yourself, your background, and just like the elevator pitch on what Global Power Technologies does.
Sure. Thanks, Zach. Thanks for having me on the podcast too. I really appreciate the opportunity. So my name is Laura Kennedy. I'm a mechanical engineer by education, but right out of school, I've always been fascinated by manufacturing and factories in general. I found myself working for quite some time with ABB, which of course manufactures a lot of different power equipment. And so over the years, I wouldn't call myself an electrical engineer, but I'm a mechanical engineer in the art of electrical product manufacturing, if that makes sense.
Yeah, that's an important niche because a lot of mechanical engineers I know really don't like electricity.
Well, I can change a light bulb, which hopefully is progress. So yes, Global Power Technologies was privatized from a public company, but is actually quite a long-standing company. We've been around for about 45 years. And what we do is provide reliable off-grid power, mostly to the oil and gas industry, but some other applications such as remote telecom or remote security, remote surveillance, that type of application. But the company exists to make sure that where there's critical devices that could be pressure sensors, for example, it could be SCADA and communications equipment, it could be cathodic protection equipment that protects gas pipelines from corrosion. We're making sure that all those devices are powered in the field for the gas industry to make sure that gas is safe for the environment, safe for people, and is as productive as possible for operational integrity.
And can you give us an idea in terms of the range of power generation solutions you guys are working with? Are we talking about kilowatts, megawatts?
Yeah, it's a great question because it's sort of an unusual niche. We actually can power as low as, say, 5 watts for an individual sensor. On a single well pad, you might be, depending on the application, you might be anywhere from 100 to 500 watts. As you get into bigger gas pads, so that's where there's multi-directional drilling that goes on under the wellhead. They might have an 8-well pad, for example. They can get up into the 1, 2, and up to maybe 5 or 6 kilowatt power range. And then when you go offshore, for example, we're looking at sometimes up to 8 or 10 kilowatts. We kind of find that above 10 kilowatts, our clients have lots of different solutions available to them from a technology perspective. So we tend to 10 kilowatts and above, although that's required. We don't focus on that area because it tends to get into bigger companies, bigger competition, and many different technologies that are available.
Yeah, absolutely. So one of the things that grabbed me when we first had a chance to talk was some of the history of the company and where the company came from. I'm a bit of a space nerd on the side, and so the evolution of the technology, your TEG technology coming out of the NASA Apollo program, really grabbed my attention. Can you give us just a quick, or go into detail if you want to, but some background in terms of your links back to that program and how the company got started?
Yeah, usually I find company history one of the more boring slides you need to present. But for our company, thankfully, there is a really interesting history. So I'm hopefully getting it right because it is going back decades. But my understanding is that NASA had engaged 3M to come up with a way to provide unlimited power on the moon for the Apollo mission. And I actually don't even know what they were trying to power, but it was DC power in the range of 75 watts. And so 3M had, I understand, hundreds of engineers working on the technology of thermoelectric power generation, and their heat source for the power generation was radioactive material. So they developed a device, they brought it to the moon in the Apollo mission. It is still on the moon today. It is still generating power today. So one of the unique qualities of a thermoelectric generator is that the product can really last for years and years and years, especially when it's a radioactive TEG or R-TEG, because you don't have any of the fuel impurities or liquids or different fuel composition that you might have, for example, with natural gas, which is one of the things that you need to just monitor in the real world. So radioactive TEGs are still in use, in particular in aerospace today. So when you hear about different missions to Mars, whether it's in movies like The Martian, which was of course based on the book The Martian, the power source that they refer to there are the radioactive TEGs, but they are in practice still manufactured, to my knowledge. Our company doesn't do that, but there are highly specialized, I think in particular in the United States, aerospace firms or specialty TEG firms who do make very unique radioactive TEG still today. So there was a group of engineers, I think 3M, after they did the Apollo mission, they didn't really feel like there was much of a market application for the TEGs. And so I think they somewhat abandoned the technology. And there was a group of engineers who created a trade secret or maintained a trade secret around the science behind this particular TEG design. And we're talking about forming a company. I assume they had some kind of permission from 3M to do that, of course. And they were avid hunters and fishermen, and they came up to Alberta to do some hunting and fishing. And while they were here, they really liked the region, I think, first of all. And second of all, there was an urban diversification tax grant that was available. So it made it attractive for them to come to Canada and set up a business, in particular in rural Alberta. So I think that was back probably over 45 years ago today. I think just about 50 years ago that they would have moved here and built the factory. We still own and operate that factory today. It's one of our two factories, and our other factory and sort of headquarters now is based in Calgary, which is about an hour and a half away. And that was just so that we'd be closer to the gas companies and have more access to a diversity of labor for engineering and technical skills. So we still have that factory today.
Cool. It's such a cool backstory, and one of the things that I think, having here echoes from a space program from 60 years ago are still driving, the history of companies today, which I find it really interesting. I want to get if you can give us like a quick scientific primer of what a TEG is and some of the concepts behind, how we take thermal energy and convert it to electricity, before we kind of get into how you're applying it and what your current markets are. Can you give us a little bit of the background of the basic concepts and some of the materials and like maybe physically what a TEG looks like today?
Sure. So I think, as with any type of power generating device, you're taking the concept of energy transfer and conservation of energy, and hundreds of years ago, there was work being done to understand and try to measure and monitor as heat transfers through different materials, whether there's electricity that flows or power that flows as a result of that. And those principles are defined as the Seebeck principle and the Peltier principles, that they were able to say that, yes, when there is heat transfer between certain materials, if there's adequate difference in the hot side and the cold side, that you can capture. We capture it in what's called the thermopile today, but you can capture that heat transfer and convert it into electricity. And then, of course, it's the art of how do you capture that and pull it together into a power unit to have the power output that you're looking for. And the best way to capture and transfer that is through DC power generation in a TEG.
Okay. So what materials are you using in modern day TEGs? Is it a bimetal device? Is it a single material?
So no, it would be multiple materials, and the material you use is a function of what the operating temperature of your product is and what the power output potential of the product is. So thermoelectric devices by the millions are manufactured around the world today, but are very, very small power output, and they would have a particular product mix in the power unit. And one of the things that makes our product unique is the material composition that is in the power unit. So the typical materials are bismuth telluride or lead telluride, germanium, but what exactly we use in which TEG is actually part of that trade secret. So we probably couldn't share what our materials are, but it's in academia, there's lots of studies done on which materials would be best and how do they perform. And there's often a few different characteristics. I mentioned temperature being one of them, but material degradation under the heat, of course, is another one. So you might end up with a very short-term power output that seems really attractive, but the power degradation over time can be quite rapid because the material is degrading because of the high heat that it might be under. So it's a matter of trying to balance the best material properties for electrical transmission along with the thermodynamic characteristics of that material for the high heat as well.
So is that, as you look at your applications, are you tuning materials and physical characteristics to a specific installation, or do you have those built to a size of the units? Your maybe a 50-watt solution is a particular material and size, and then the I don't know how big you go, but maybe the 800-watt solution is a different size and material. And is that tuned to the kind of continuous output, or are there other factors in terms of material selection?
Yeah, so our material selection across our power units is pretty much the same. It's the way that you configure the power units inside, the thermal piles inside the power unit, and the way that you distribute the heat and pull the cold out of the cold side of the power unit that really determines how much power you get. But we have very specific unit models, and currently on the market, for example, we have 50 watt, 100 watt, 200 watt, and 500 watt. So 4 power sizes, and those are our units. The TEG is a highly tuned and very precise burner management system around getting the exact heat and repeatable heat and steady heat from the burner. So the burner design is a tricky part of designing a TEG, as is the configuration of the power unit, and then the air and cooling that goes all along with that. So we can configure solutions then to serve the application. But they are absolutely standard products. It would be a huge undertaking to design a TEG for an exact power output.
Yeah. So can you give us a concept? This is an audio format here, so we can't just put up a picture for folks, but can you give us a concept of what the basic kind of construction elements of your TEG lineup are? Because in the most case, you're burning natural gas, right? And that's the heat source. So you've got a natural gas burner for the hot side. How is that interface to the TEG? Is there a heat exchanger or just a thermal layer? And then what does the cold side look like? And what are you doing to actually move heat to and cold air to the TEG?
Yeah, so that's absolutely right. So fuel comes into the burner, and the burner, the way that it works in each TEG is slightly different. Sometimes there's a pilot, sometimes there's not, or the way the pilot runs during operation might vary as well. And then we're really going for a very specific flame propagation or format against that power unit. So sometimes the power unit might be flat, or it could be round or cylindrical. And so the way you want that flame to propagate depends on what that power unit configuration is. But that's what we call the hot side then, is where the flame is heating up the hot side of the power unit. And then the cold side really can look different from one teg to another. So in some cases, it's a box that I would say, trying to think of something similar in size, sort of like a school locker. If you imagine that, a half height school locker is about the size of our smaller tegs, and they do look mostly like a long rectangular box. And the cooling on the cold side is, of course, inside that box, where you've got fins where you're trying to distribute that heat as quickly as possible with the most surface area possible. And then just because you're going from hot to cold, the heat naturally is rising, of course, and that's going to pull through and draw up air across those cooling fins to have the best flow rate across those for the best cooling opportunity. Some of our bigger units, depending on which unit is, you can also have a passive heat pipe where glycol will naturally just rise and fall as it heats and cools, to draw the heat away as quickly as possible in some of our bigger units. But the bigger units do tend to be cylindrical and quite big. So I would say probably as big as a large fridge for a home, for example, and a cylindrical in shape at the top. And they sort of look almost space aged, actually, just because of the way the fins are configured. It kind of comes up in a big circular format, and they are quite unusual to look at. And around the world, power equipment often gets stolen, whether it's for the copper content or for components, or it happens everywhere in developing nations as well as first world countries. And the interesting thing is almost nobody steals a teg. And I think it's because it looks so weird. Is that because they don't know what it is, or people are afraid of what it is? And if you get close to it, it is hot. I wouldn't. It would be hard to burn yourself on it, but it would certainly hurt if you were to touch it for a longer period of time. They are quite quiet. So you wouldn't really know, is it fully running? Is it fully on? What am I touching and what am I standing close to? Because that's one of the benefits to them, is that they are very quiet. And of course, if you were to investigate and think, is this something I'd like to steal? You would notice that it has both, of course, the gas intake as well as electrical cables out. And so you'd have to be a pretty sophisticated thief to be able to steal a thermoelectric device and to know what to do with it.
Yeah, it's kind of security through obscurity a little bit.
Yeah,
I don't know what it is, so maybe not touch it. So maybe we can get into, I guess, before we get into the actual application and the use case for the tags, what kind of total system efficiencies are we talking about here from the I guess the total gas content, like thermal efficiency to electrical conversion? It's an internal combustion engine is going to be somewhere around 40 or mid 40% range. Where are you currently at with tags?
Yeah, so efficiency certainly is one of the drawbacks of a teg. It's nowhere near the internal combustion engine, so we're down at about a quarter or less. The efficiency of the teg really depends on the ambient conditions. So we'll rate the power output of our teg at 20 degrees Celsius, which I'm going to do quick math and say that's somewhere in the 70s Fahrenheit.
Yep.
But of course, if it's operating at much colder conditions in the winter, the power output will go up. So the efficiency is tied to the ambient temperature, because of course you can cool faster when the ambient conditions are colder. But yeah, so it is low efficiency, which is one of the reasons that we can talk about later, maybe, of why we pair it with a solar and battery when there's concerns for emissions or fuel consumption. If you're on tanked fuel as opposed to pipeline fuel, for example, and you're trying to conserve how much fuel you're using, then pairing a teg with solar panels and batteries is a really good way to go. But the efficiency being low, I would say is the drawback of the technology. But where you lose out there, I think you gain in reliability, and the part of the reliability and low maintenance requirements of a TEG is tied to the fact that there are no moving parts. So if you imagine, of course, a combustion engine, there are moving parts, and that's where you require the maintenance in several different areas, of course, of the engine, including teardowns and different maintenance intervals. And whereas a TEG, if you've got clean gas in, you're really just checking and changing a filter occasionally, but very, very little maintenance required, and the power degradation over time is extremely low. So we have clients who might run the product in the field for 5 years without even touching it. And after 5 years, they'll phone and say, geez, what's going on here? I don't have the same power unit or power that I used to. There's something wrong with this product. You said it would last 20 years. And so we'll say, well, can you just send us your maintenance records? What have you done in the past 5 years? And they have no maintenance records. So we'll quickly walk them through a very simple field maintenance and a check, and they'll be back up and running and producing full rated power, again, pretty quickly in most cases. So we do have clients who run them for 20, 30 years. They send them back into us for a bit of an overhaul after an extended run period of decades. And we can do a little bit of service, and in most cases even get them that same unit back out and running if that's what they're interested in. So there are trade-offs, but lots of benefits that make it appropriate in certain applications.
Yeah, so the first parallel that came to my mind was looking at some of these like small hydro systems, for example, what they make a kilowatt at a time or something, but compared to solar or other things, it's continuous. It's all the time. And if you pair it with a battery system, you can slowly refill that bucket and have a high reliability kind of always on power source, which is very much different than like wind or solar or any other kind of off-grid, generation solution that's out there, right?
Yeah, I think it pairs well. Like, I think the future for our business and for the TEG industry will likely be people wanting to pair it with solar and battery just for that overall lowest greenhouse gas emission potential of the technology. But when you compare it to, for example, a fuel cell, which people can look at a fuel cell, say very high efficiency, but really specific fuel composition requirements in many cases for a fuel cell, and sometimes a shorter product life or a limited product run time, which you don't see with the TEG. So lots of great fuel cell research being done. I think there's great potential in the future of fuel cells. But for now, I think it's a niche product, absolutely, but there really is some great applications and great reasons for why a TEG makes sense in some of these really critical off-grid applications.
Well, yeah, let's jump into some of those. So, you're in remote areas of, Alaska, Canada, wherever. You've got either well or gas equipment, right, that needs power to either function and or communicate. And so is that the main use case? We just need off-grid small amount of remote power just for monitoring and SCADA systems, or are they being used for other functions on the pipeline?
Yeah, that's absolutely right. A lot of it is for sensor power and for communication power, different types of communication devices, and any kind of specialized equipment that might be electrically powered on site at a wellhead, for example. And then all along a pipeline, right? A pipeline needs to be continuously monitored for the safety of the environment and the safety of the people and the integrity of the fuel. So as an example, if you're going to cross a body of water, a river, for example, with a pipeline, you'll want to measure what's the gas pressure before we go into the river, what's the gas pressure after we come out or have crossed over the river. Is it the same, right? Because that's how they're monitoring is there any environmental risk to the pipeline that they're operating? And so having real-time data and reliable data from all of those pressure sensors or different equipment along the length of the pipeline is the type of critical power that's needed. And imagine a lot of these are in forests. And so your ability to have solar power is limited, although it can be done, but you're either putting a solar panel quite high on a pole, for example, or you'd need to be cutting down trees to make sure you don't have the shading in the winter. Those types of, there are some challenges to having solar all along a pipeline or at different wellhead locations where often you're trying to limit your environmental impact. And so it's sort of a catch-22. You either need to clear the land, or mount the equipment really high, and sometimes your neighbors, be that indigenous communities or farmers, or they just don't want really big solar installations mounted on a tower or on a pole. So there's different trade-offs, right? Any of these solutions, there's trade-offs, but those are the types of applications. Cathodic protection is another one along a pipeline where basically you have a sacrificial anode to take the corrosion so that you protect or limit the corrosion in a pipeline, very similar to the marine industry where they do the same on ships. And that sacrificial anode has a current running through it to help draw the corrosion to that anode. And so that's an example of something that we could power. But more and more what we're seeing is a demand for electrification and for power to environmental solutions as well. So that's a newer application in our industry where people need power and sometimes need more power than what we could have provided with a TEG. And you're powering equipment specifically for lower emissions or higher efficiency or methane destruction or methane elimination.
Well, that's a great segue into my next question. That there's your primary market is gas and oil, and that whole industry's been going through quite a lot of change. There's a big push for reduction in methane emissions and for generally cleaner operations and for lower carbon footprint for the things that they're already doing. And so that's changed the way that I take it that you've started addressing that industry, and you guys are expanding your product portfolio to offer some different solutions that address some of those specific problems, right? So can you talk to us about, I know you guys just launched this product, and I watched the webinar. It was very informative, but can you tell us about what the MX generator, what its target market is, kind of how you're addressing that problem differently than they might with a TEG, and just scope that MX product for us?
Yeah, thanks, Zach. So our market really is changing. The energy security is a big topic, as you know, and then energy efficiency and reduction of emissions. And having the cleanest molecule of gas is definitely a target for many countries or regions or producers, because I think not only does it impact your domestic footprint for greenhouse gas, but it can make you more attractive for export as well. So many different regions have LNG or liquefied natural gas terminals, and your ability to run those terminals requires you to keep them full. And so you want the demand side of that LNG terminal to be good. And the best way to do that is to have not only cost competitive gas prices as much as possible, but also to have the cleanest production of that commodity going into that natural gas terminal or LNG terminal. So there is a lot of competition to become more green and to demonstrate how you're green. And in Canada and the United States, I think we're starting to capture what we would call the low-hanging fruit of that lower emissions opportunities. So one of the best examples is the whole field of pneumatics. And so the gas industry was built on installing quite affordable and highly reliable pneumatic devices. These might be valves, they might be pumps, and so on. And the beauty of it is you already had the pressurized gas on hand. So you sometimes didn't even need power at a well if you didn't need the power for monitoring or sending data. All you needed was a handful of pneumatic valves, and you could run a very simple well in a cost-effective way. But of course, a pneumatic, every time it actuates or performs the duty that it's there to perform, it vents or releases a small amount of gas. And historically, I think we didn't think about that, or maybe we thought about it, but we felt like, there wasn't the economic drive or the desire to do anything about that. And that has changed immensely. And so what you need to consider is when you vent that gas, what is the content of that gas? And natural gas across North America often has a very high methane content. And methane, when you equate it into an equivalent CO2, so often that's the way you measure your greenhouse gases, is you turn it into an equivalent CO2 measure, which is often measured in tons of CO2 equivalent. TCO2e is what it gets referred to as, but methane is much higher than carbon dioxide itself. So it might have a 25, 26 multiple in TCO2e. Yeah. So the methane content, if it's high at 80 or 90% in that range, you need to stop venting those pneumatics. So you've got a few different options. First, the easiest thing you can do is go from a high bleed to a low bleed device, which many producers are already doing. And then you can also consider, well, how do I put something else down the line instead of the natural gas? And so that's becoming quite a common solution today, which is to have the power available to compress air and then put air down your instrument line, so that now when the pneumatic valve is venting or releasing the pressure, it's releasing air, plain old air. And so if you have grid power available, that you probably would have been doing this already, but the challenge is, how do you do that when you don't have power at the site? Because a lot of these bigger pads, which have more pneumatics, they will require anywhere from 3 to 4 to 5, maybe up to 6 kilowatts to be able to generate enough air at sufficient sufficient pressure with adequate flow rate to be able to support all the pneumatics on that site. So what we saw was that the TAG wasn't the appropriate solution to get up into that 5 or 6 kilowatt range. And we really wanted to find the most efficient solution or technology available to be able to put something into the field for the high reliability, low maintenance that we're looking for, but to keep the emissions as low as possible and the fuel efficiency as high as possible. And after a lot of research, we said, you don't need to be new to be good. So we turned to the internal combustion engine, because although it's old technology, the efficiency of an internal combustion engine is very, very competitive in the field today. So we're competing with companies who offer similar solutions using Stirling engines, which are external combustion engines, and their efficiency is about half that of an internal combustion engine, and that equates to double the emissions. So relative to newer technologies that call themselves clean tech or green, an internal combustion engine, when run properly and designed properly for emissions and efficiency, is actually really competitive, even with what people call new technology or clean tech. It really is still a great solution. So, we paired a Japanese OEM engine together with the alternator and balance of plant equipment to be able to design our own 6 kilowatt generator or KVA generator. And we had that tested in an EPA lab and received EPA certification, so that we know that it meets all the requirements for sale into the United States and Canada. And of course, that EPA certification is suitable for many regions around the world as demonstrating that it is a clean device.
Yeah. Well, this is going to show some of my ignorance of the oil field industry, but as I was watching your presentation, then, Googling stuff as I was hearing about it. It was kind of crazy to me to hear that they're just venting methane to run valves and pneumatics. So the entire concept of instrument air was like strange to me. But also the fact that people are still using external combustion or Stirling engines in real world applications was also news to me. It's something that I've come across before. So it seems like really good to see the industry, I think, embracing some of these other changes and really being conscious of what their CO2 output, what their carbon footprint looks like to run these sites, because it's essentially free to run those valves on methane, right? It's gonna cost more money to put the infrastructure in to have, clean atmospheric instrument air as opposed to using methane. So it's not a cheap thing to do. You're gonna have to go and spend the money to solve that problem.
Well, it's interesting you bring that up because it depends on where you're operating. But the carbon credit trading program that exists internationally today, often you can recover the capex that you have paid for the equipment. You can recover it in about a year, I would say. And of course, these devices are going to run on these wells for hopefully decades. So there's absolutely a revenue potential to it, depending on sort of what your regulations are. And there's lots behind it. But in Alberta, for example, there are carbon credits at $50 per T of CO2 abated. And it does certainly become the carbon trading does make it economical for companies to participate in that. And we also see some really big projects where there's investors, for example, who will install various equipment, not just instrument air solutions, but environmental solutions in the gas industry, maybe are installed in the Middle East. And the carbon credits that are generated by installing that equipment are sold into Germany. So there's a huge international carbon trading aspect that makes it not only the right thing to do for companies to be able to decrease their emissions, but it makes it economical for them to do that as well.
Yeah, that's an entirely other market, right? Introducing a new set of incentives to change the behavior.
That's right. Yeah.
Very interesting. I wanted to ask you a couple of questions about the engine certification process. So you guys went through the certification process yourselves, and you hold the certificate for the engine for US EPA in Canada. Not something a lot of people go do to build a new product. So how long did that take you, and what was the decision-making process like around going to an engine that didn't have the certification you needed versus looking for an off-the-shelf solution? So what were some of the decision criteria behind going that route?
So it comes back a little bit to what we were saying before, is that in that 10 kilowatt and above range, I don't compete because I know there's lots of solutions out there. So when we were considering which engine to integrate into our solution, we wanted a target power output of about 5 or 6 kilowatts. We wanted to make sure that we were operating at one of the higher efficiency ranges of the engine. We didn't want to have a really large engine that you're turning down because you'd lose out on that efficiency potential of the engine. Mm-hmm. And there are very few or none, I might say, that met the criteria that we wanted in that power range that had EPA certification. So some of our competitors, they have business models where they are buying an EPA engine to save that product development process time and the risk and complexity of certification. But it means that they end up with a lower efficiency, higher emission product for the same power range in the end. So we felt that it was important to do that, to be as competitive as possible on emissions, and we feel like that'll be a driving competitive advantage. But it takes I'm going to say it took us about 9 months. So we do our own internal testing. We try to replicate the testing that will be done in the EPA lab. So we do that ourselves in our factory here in Calgary. And then once we feel like we've met the criteria for what they're going to be testing in the EPA lab, we send the unit down to them, and they replicate those tests in their facilities. And I have to say, it's a really collaborative process. You might think it's a bit adversarial, but if they have any trouble either with the running parameters of our engine or anything about the design of our product. We don't send them our final product. There's only a certain scope we need to send them. So it's not here's the button to turn it on. There's a little bit around getting it running, because it's just the heart of the engine that you're trying to test. Very collaborative, and we're really pleased with the results. We exceeded the requirements for the EPA rating, and then we had a company in the United States who was helping us with the paperwork, because maybe the paperwork to actually apply for the certification is the more complicated part, to make sure you provide the right information at the right interval and so on. So we certainly had to reach out to get help to do that.
Yeah, that's my understanding too. But it's it's not just an easy undertaking to go get an EPA certification on a new engine. So I applaud you guys for getting it done in such a time frame too. We've seen some of those certifications take several years with other companies. So congratulations.
Yeah, thanks for that. We've got a great team of engineers who are really focused on helping us do that quickly, and they did a great job. So thanks. We're really proud of that.
So the MX series, you're also pairing that with a compressed air solution, right? So are you offering it as a power unit alone, 6 kilowatt, 6 kVA generator set, if you only need electrical power, or that plus an air solution?
Yeah, absolutely. So we try to be flexible in what we offer to our clients. So there are some operators who have a standard brand of compressor that they like to use, and there's good reason to do that. Right across the field, you can have all the spare parts, and your team is trained on those compressors, and you probably have some preferential pricing because you've standardized on those solutions. And we're happy to provide power to those solutions. So the MX can provide both single phase and 3-phase power. We have clients who use both and like both for different reasons. And so those are some of the options. We can also work with third-party integrators. So there are integrators out there who their main market is instrument air. And historically, they've provided instrument air systems on grid. So now they've got a built-up clientele and a strong market and great reliability and great service, but they don't have power. So that's another source of where you can, we work with those types of companies to provide power to their integrated solution. And then there are clients who just want a packaged solution, right? They just want you to give them something that they know will works efficiently, works well together. There's data collection on all the system to provide system performance in a simple way across the instrument air solution and the power. And that's what we can provide. So we offer 2 horsepower, 3 horsepower, and 5 horsepower air solutions. In that, you would obviously always be wanting to dry the air to make sure you protect your instrument air line and the equipment downstream. So you're drying the air, and depending on how much horsepower of air you're putting through, the rest of the power can be used on other devices on the site, or you would just, obviously the engine's going to ramp up, ramp down to accommodate the load that's required throughout the life of that production cycle. So some power left over with the air as well.
Just comparing some of the features and benefits from the TEG back to the MX solution, one of the advantages of the TEG is you can put it on a site and not have to perform regular maintenance on it. And one of the main drawbacks of an IC engine in that application is that we do have a regular and preventative maintenance required. So what kind of work or what kind of maintenance intervals have you been able to achieve with the MX series generator to try to address that primary difference?
Yeah, so great question. So one thing we didn't talk about is that almost all of the sites that we're powering are unmanned. And so you might have somebody going to site. Sometimes it's weekly, often it's less than that, and sometimes it's quarterly and sometimes it's annually. So we have some sites, for example, that the only access is either by a winter ice road, or it could be by helicopter. So very expensive to get in and out of those sites. So almost all of our systems we design with an annual maintenance cycle as our target, which is far longer than a lot of gen sets would be able to run. So there's a number of things that we do to try to make sure that we can achieve that long run engine design. And, the most obvious one, the simple one, is that you have a long run oil sump. So you oversize your oil sump to require less frequent oil changes, for example. But it's also in the selection of the oil that we use, obviously highest quality for longest run, so very specific oil requirement, as well as the coolant. So we're really looking at those consumables that maybe you'd trade off for something cheaper or more easily available, but we do have higher quality requirements to help extend the maintenance life cycle. The way we manage the engine temperature also helps to extend or balance out that lifetime between maintenance cycles. And then there's just some startup and shutdown procedures that you're trying to handle the engine as gently as possible during startup and shutdown. And then once it's running and in that operating parameter that it's going to be in the field, that's all managed by our system so that you're not providing any kind of thermal shock to the system. So there's a number of different things that are built into our design to help have that 1 year maintenance interval. And I think that's what the clients need and require, so that their operating expense is low and that they're not having to make extra trips to site.
Yeah, I mean, especially for something that I'm assuming runs. Does the MX run continuously, or is it called to turn on based on instrument demand or something else, or is it kind of always running waiting for load?
Yeah, so in a lot of these bigger applications, I would say that it's running continuously according to the load that's there, but it absolutely can be remotely started and stopped, and it could operate in sort of what we call a keep alive program, especially in colder regions. So in a cold region, it will monitor, does it need to start itself to keep the batteries adequately charged? Or does it need to start itself because it's just getting so cold that it needs to bring its temperature back up and then let the temperature fall back down again? So it is possible to have it turn off for periods of time and turn back on as it needs to. So it really, the MX could run in either scenario, but most of our clients would have it running most of the time, I would say.
Yeah. So you're getting up into those, somewhere north of 5,000 hours of runtime between intervals.
Yeah, even as high 8,000 to 10,000 hours, depending on how you're using the engine and so on. But absolutely up above 5,000 into 10,000 hours.
Yeah, I mean, that's like, 10x what the normal market for an IC engine is in terms of maintenance intervals. That's a huge difference.
Absolutely. That's right.
Yeah. I wanted to know also, we've done a bunch of different applications for some extreme environments, but, especially when you get into Canada, Alaska, and some of those northern environments, the extreme cold makes running and operating an engine really difficult. So were there any special countermeasures that you guys have deployed for some of the extreme cold environments, or do you make like an Arctic package for the MX, or is it kind of all weather hardened, or how did you manage some of those cold environment issues?
Yeah, so in our factory in Calgary, we have a thermal chamber that can run from about -40 to +60. So cold is difficult, but hot is difficult as well. So we have clients who need to know that will it start and stop at -40? Can you remote start and stop at -40? Will it run and operate at -40? So typically, once you're up and running, -40 is not really a problem because, of course, the engine's going to keep itself warm. So it's the start and stop. But when it is running, you have to think about things like how much condensation's in the exhaust. And it will freeze, right? On a cold, windy day in the prairies, your exhaust, if you have any condensation in that exhaust line, it can freeze. And you'll start to get sort of these big icicle buildups between your exhaust and the ground. And of course, if that gets to a point where you can eventually clog up and block the exhaust flow, which of course would not be good. But the gas itself is also a problem. So sometimes you need to think about how can we heat. If it's a propane tank, you'd want to heat the tank, you'd want to heat the line or preheat or vaporize the line to make sure that the gas isn't getting too cold. cold. And lots of things just about how we run, like I was mentioning, that Keep Alive type program in the cold. So it is a challenge. Minus 40, I would say, is what's expected, certainly north of the border. And then in the States, you're looking at often that 105, 110, down into certain Central American countries that we sell into as well. They're looking into that temperature range. And one of the more difficult things for us, believe it or not, is just the solar loading on the engine. So we can run and test the systems up to 60 degrees in our thermal chamber, but really understanding what happens when you've got 12 hours of really hot sun beating down on that unit, what impact does that have on the internal operating temperature and operating limitations of the engine? So we've done a lot of that testing and modeling as well, and we've got really high temperature performance on the MX, and of course you do start to see power degradation at quite a high temperature, and we offer degradation curves to clients who are operating in hot environments so that they can start to understand at what point will the load start to need to decrease, or when would you maybe switch to really critical loads and turn off some loads to start to accommodate some of that power degradation at the really top end operating temperatures. But certainly really hot, really cold, both challenges, and our product is designed to meet both ends of the spectrum.
Yeah, I think it's kind of hard to understate how much engineering work goes into making a product that can operate from negative 40 to 110 degree ambient conditions. There's a lot of work and a lot of little factors in terms of getting that right. So, I understand how much work that is. I think a lot of people just assume it's well, just throw a battery heater on it and put a bigger cooler on it, you'll be fine, right? It's a little more complicated than that.
Yeah, and when you've got people on site to monitor it or to move things around or change things, it's different. But when it needs to figure it all out itself and be able to manage it itself, then that's a little bit more challenging again.
Yeah. I also know that you guys have done some work with solar hybrid solutions. Is that in complement to the MX generator with solar hybrid solutions? And it feels like you're moving into an ecosystem where you can kind of mix and match your power generation with battery systems for a specific client or specific site. But can you talk about what your strategy is overall between these three different generating solutions, and presumably like a battery storage option that goes with it?
Yeah, absolutely. So off-grid solar power and hybrid off-grid solar power is very different than on-grid. So, for example, lots of houses now are getting solar panels put on the roof, but you've always got the grid there. Right. So, on a beautiful day, you'll say, wow, look how great solar is. I've produced lots of power. But you don't really worry when it's cloudy. The grid's always going to kick in. So if you imagine sort of a typical solar panel that you see on a roof, they're often 300, 350 watt panels, just to sort of start with sizing there. And then if you consider that in Canada, we might often use an 8 or a 10 times multiple for sizing the solar system. So a 100 watt load, for example, if we're putting it on an unmanned site where it's high reliability requirement, you might need 800 watts of solar panels. And so you're looking at 2 to 4 solar panels typically just for 100 watts, right? Very small load. And then the way that you size your battery takes into consideration any peak demand in the load. So your solar would be sized to the average load requirement. Your peak demand, you could size your battery to accommodate peak demand, and your battery is also sized for the number of hours or the number of days of autonomy that you want for that system. So typically what you would do is look at where is this solar system going to operate, and in let's call it a bad year, maybe not a worst case year, but in a bad year, how many days is it possible that I won't be generating adequate solar power? And that's how you'd want to charge your or size your battery.
Yep.
And the reason I talk about all that is that in that TEG power range, from 100 to 500 watts, like we were talking about, or 500 and below, what you tend to find is that that's a good size for a hybrid system, because if I can put a tag in with the solar system, I can probably decrease the number of solar panels that I need, and I can decrease the battery size that I need. So I'm going to have a smaller footprint, I'm going to have lower capital, and I'm going to end up with an overall higher reliability for that system. And on a wellhead or a pipeline, it's probably a realistic amount of square footage or footprint for that solar. Once you get up into the MX range of things, up above 1 kilowatt, the amount of solar and the amount of battery that you need to really make the system feasible gets to be pretty unwieldy pretty quickly. So on the MX, we typically, on a smaller system application in that 1 kilowatt type range, and in an extreme environment, for example, we're doing some work in the Arctic, like you were talking about, and there we're looking at pairing it with solar and wind and battery and engine. And that's because your ability to provide fuel to those sites is very, very limited. There's a 3-week window once a year to get fuel to those sites. But obviously that's a very, very extreme application of off-grid power. So I would say that most clients, I think if you go with a very high efficiency engine like the MX, if we compare it to some hybrid solutions that do have the solar, the battery, and the engine, but they're using a larger engine, so they don't have the efficiency that the MX does. So what we're seeing is that the fuel consumption in the summer in Canada of an MX is equal to a hybrid solar solution for the same power output. And then in the winter, the MX is going to far surpass that, of course, because you don't have near the solar power generation available on those hybrid systems. So, solar really is an attractive solution. For us, we say it's really good up to, in most situations, it's really good in that 10, 20, 50 watt range. Getting up to 100, you might be starting to run out of land space, or you might have tree coverage, or you might be in a valley, or all those types of limitations. So certainly lots to consider for hybrids, but really good potential. We also see clients who have a solar installation with just the solar panels and the batteries, and they'll buy a tag to improve the reliability, because they'll say, we don't have any more footprint, we don't want to spend more on batteries, can we buy a tag and maybe it'll turn on 5 times a year? And so there's ways to add a tag to make your solar system more reliable, or you can buy the solar to make your tag system lower emissions. So there's both going on in the market today.
Yeah, you guys have really kind of built out a Swiss Army knife of solutions that can be catered to individual sites. It's really interesting.
Yeah, it's fascinating. We're working on a product that we're excited about the release coming soon, but the whole reason there's demand for that product is even at a very, very small power range, solar is not always reliable enough. So if you imagine the natural gas that goes to your community and your home, there are pressure sensors all along that line as well. Yep. And those pressure sensors might be anywhere from 4 watts to 8 watts. So, fantastic idea by the utilities all across North America. They all started to say, look, let's power those with battery, or let's power those with solar panels, because why would you tie it into the electrical grid? You'll be paying more for the electrical connection than you will for the electricity consumed, right? Just the base cost of running power to one device is the same as the base cost probably you have to your house. But what they find is either with snow, with leaves, with theft of the solar panels, theft of the batteries, the battery dying because of extreme heat, the battery dying because of extreme cold, or cycling that is just hard on the batteries. There is still demand and a need. Again, it's on those critical devices that if that pressure sensor fails in your neighborhood and there's a pressure spike in the distribution pipeline to your home, that creates a high risk for explosion. which of course nobody wants, but the utility companies also don't want. So there is that trade-off between the environmental solution, but the critical reliability when human lives or the environment are at stake.
Yeah. It's a challenging set of conditions to design around, I'm sure.
That's right.
Well, Laura, I want to thank you for joining me, and congratulations on launching a new product. I know that's a huge undertaking, so hopefully you've got kind of a big sigh of relief being able to put that out into the market and get it into production. So congratulations. And where can people find you if they want to learn more about Global Power Technologies?
Yeah, thanks, Zach. So our website is globalTE, the letter T as in Tom and E as in elephant.com. So our website's really the best place to go to get more information. We try to provide information on off-grid power overall. There is a white paper that can be requested that tries to give a fair analysis of all the different options. And I hope one of the things that I've left your listeners with today is that there is no one solution that's going to be best for everything, right? Yeah. There's many, many different approaches and depends on where you are and what your goals are and so on. And, I really do appreciate the opportunity, Zach. I think it is a lot of fun to get a product launched and into the market. But as soon as you've launched one, you realize you're late on the next one you want to launch. So it probably becomes a bit of an obsession that you feel like, okay, we're happy with what we did and what are we doing next? Because there is something better and something coming next. And it is exciting. And I think your podcast does a really good job of maintaining that excitement, right? About how do we learn about what other people do and why don't we borrow or steal great ideas from other people and learn from other people about what they're doing in that same space. So really appreciate you inviting us to the podcast.
Well, thanks for joining us and take care, Laura.
Thanks very much, Zach.
Thanks for listening to Engineuity. We record and release a new episode every month. Be sure to follow us at Engineuity Podcast on Instagram for updates about future episodes and industry news.